Hello again. Today I'd like to talk about the copper piping that we use to connect all of the air conditioning components together. There's really a lot to talk about here with this subject because I don't want to just talk about the different types of piping that we use, the different sizes, but I also want to go into some detail on what we do with that piping. We have to cut it, we have to bend it, we have to clean it, we have to braise it together. Then once everything's together, we have to leak check it to make sure there are no leaks. So there's a lot of different varieties of things we do to it and many different methods to accomplish those things. So today I'd like to get into some of those things that we do and the different tools we use to accomplish them. So let's get started. Okay, what I've got here is some copper pipe that we're using on the Mace shuttle to connect all of the components together. And what I'd like to make sure I get across first is that the sizing of HVAC pipe uses a different standard than the plumbing profession. The plumbing profession is using the inside diameter, whereas the HVAC industry is using the outside diameter. So whenever you hear me reference a copper pipe size or even a fitting for the pipe, I'm always going to be referencing the outside diameter since that is what the HVAC profession uses. The largest amount of pipe that we use is 1/4-inch pipe. 1/4-inch pipe is what connects the condenser to the compressors and the condensers to the evaporators. And that's always going to be 1/4-inch pipe. We're also using a 3/8-inch line. And the only thing that uses the 3/8-inch line is the suction line between the evaporators and the compressors. It's a large, long run, but it's the only section that we need 3/8-inch pipe for. The other size that I've been using with any frequency when I do these installs is a 1/2-inch copper pipe. And you might remember that when I was talking about the evaporators, the suction line going to the evaporator has to get brazed to a 3/4-inch piece of pipe. I do that step down with this 1/2-inch copper pipe. So those are the three primary types of pipe or sizes of pipe that we use. The other important thing when it comes to storing the pipe is to make sure that the ends are always sealed. They don't have to be airtight necessarily. The tighter the better, because what we're really trying to do is to keep the debris and atmospheric water out of these pipes. The tighter the seal, the better off we are. So whenever it's being stored, whenever it's laying around, do make sure that those ends are sealed. In general, there are three primary different types of pipe. There's a K, an L, and an M. They vary based on the wall thickness of the pipe itself. And as you can see here, what I've been using is type L. Works great, it's middle of the road, and it's easy to work with. You also want to make sure that you don't get rigid pipe. We use a lot of bends in each and every piece of each and every section of the pipe that we cut. And it's very difficult to make bends in rigid pipe. So you want something that's annealed, something that's been softened so that it can be bent somewhat easily. And when bending the pipe, you want to make sure you have a good pipe bender on hand. I don't recommend regularly doing hand bends because it is easy to kink the pipe, and the bigger the diameter of the pipe, the more easy it is to kink. It's not necessary to heat it up before you bend it, but if you do have a good pipe bender, that's the best way to manage that. Another thing we're doing, of course, when we're working with the copper pipe is cutting it into appropriate segments and lengths. I've been using the rigid cutter. I have a larger sized cutter here. I have a smaller one here for when I get into these tight spaces like in and around the evaporator. And I use both of them regularly, and they're very handy to have. Whenever you're cutting the pipe, you want to make sure you have some deburring tools to deburr the cut end so that any of those loose burrs can be removed and taken out of the pipe. They can create occlusions inside of the lines, so you want to get rid of them while you can. And of course, we've been doing recently more and more brazing of our pipe. We've gotten rid of all of the mechanical fittings. We no longer use them. We found that they leaked too much. It's not good for the environment. It's not good for our bottom line. So we've totally gotten away from the mechanical fittings, and we're now brazing all of our pipe segments together. And of course, to do that, you need to get enough heat in order to weld the two segments together. Oxyacetylene torches will do that. That's what I have here. This one was a simple porta-torch that I believe was purchased from a big box store. Comes with 12-foot of hose, an oxygen tank that I think is 20 cubic feet big, and the acetylene tank, which is half as big. If you're using them a lot, you will be refilling them pretty often because they're not that big, and you'll learn rapidly to not leave these valves open if you're just sitting around idle. They do tend to leak. When I bought the torch, the tanks are empty, so the first thing I had to go do was to fill them up. I also tried using their Harris torch handle, and I think this is just a standard number 2 tip. And it worked fine for a while, but after doing some research and through trial and error, I found that using this Uniweld's 5-flame, what they call the proprietary name's Captain Hook tip. There's basically 5 different flames that come out of this guy, and that creates a very equal heating on all surfaces of the pipe. So when you're heating the pipe, if this were a piece of pipe, you're actually heating behind it, on the sides of it, and in front of it, all at the same time. And that's very handy. It makes the brazing process, in my opinion, much easier to do. So I've been using almost exclusively this Captain Hook from Uniweld. The Captain and Hook won't fit on the Harris handle that came with the unit, so I did end up having to buy a Uniweld handle in order for that tip to fit on. But it's been well worth the cost. I think together I might have $200 in those 2 items. Of course, you're going to need a striker to get it started, and I think I'll take just a minute here, just a second or two, to show the flame that you can get with this 5-flame tip. And you can see right now, not sure why. There we go. So there's all 5 flames. It gets very hot all the way around the piece of pipe that you're heating up, and I find it extremely useful to use in brazing the pipe, and this I would totally recommend. There is something that a lot of people that braise pipe don't appreciate as much as we all should, and that's the formation of oxidation inside of the copper pipe when you heat it up. The less amount of heat that you put on a pipe in any one given spot, the less oxidation you're going to have. So as black as the pipe can get on the outside, it can also get black on the inside. And those black oxidation flakes can be dislodged, and they can create problems inside of the line later when you're charging and running the air conditioning system. So it's wise to use nitrogen. I've got a bottle of nitrogen over here. So this is a nitrogen bottle. So it's anytime you're brazing the copper lines, it's wise to use nitrogen to run through the line as you're brazing it. It's not flammable, it won't explode on you, and it will keep the inside of the pipe from oxidizing. Of course, whenever you use a tank of nitrogen, this is what they call dry nitrogen, you're going to need a regulator. This is just your standard, ordinary regulator. And most ordinary standard regulators won't allow you to really fine-tune with this handle or here at the regulator. These things won't let you regulate very small amounts of flow. You don't want to be using a lot of nitrogen when you're brazing these things. You just need a small amount running through it at any one given time. And that's why I use this NitroView. This is a nice little addition that I always have connected to my primary regulator. And by turning this knob, I can watch the orange ball here in the glass. And once it's to the appropriate level, it says, maybe you can see, maybe you can't, it says braise here. So when that orange ball gets up to that area, I know I've got about 3 to 5 CFM. And that's all I need to do the brazing to eliminate the oxidation. So this is an extremely critical piece to have if you're going to be brazing pipe and running nitrogen through it at the same time. When I braze the pipe, the majority of what I'm using is 56% silver solder. I also, on occasion, use a little 15% silver solder. This is called Silphos. It has the phosphorus embedded in it, so you don't have to use any flux with this. However, when you're using the 56% silver, you're going to need some flux, and that helps it to run into the joint much better than without. So most of what I'm using is the 50%, 56% with the flux. But if I've got a large gap somewhere, it's a really big gap, I tend to use this 15% because it doesn't run as easily, and it takes a little more heat to get it to melt. And for those big gaps, I can actually fill in much better than I can with this much softer silver solder. Whenever you're working with pipe, copper pipe, and having to join it together, cut segments out that have been damaged, it's always nice to have some fittings to do that. So I keep plenty of 1/4 inch and 3/8 joiners on hand so I can do that, especially in tight spots. Whenever brazing the joints, it's critical to keep the joined ends as clean as possible. It allows the joint to be more thoroughly welded together. So I use your basic scrubbing pads. There's also this abrasive mesh that you can buy. This is a 1.5 inch wide mesh. That works really good to keep the ends of the joined ends of the copper pipe good and clean before you actually braise them together. Cleaning out the inside of the pipe is also important when you're braising it together. And so I keep a 1/4 inch and a 3/8 inch pipe cleaner on hand to do that. I also have some larger brushes to knock the oxidation off the exterior of the brazed pipe, so I can thoroughly check and make sure there aren't any pits or voids that I didn't have enough silver solder brazed into. Having mirrors to inspect behind or off to the side of your brazed joint is also a critical thing to have. Underneath the car, when you're brazing the condensers, those are some very tight areas that you simply can't see without one of these. So important to have a mirror for inspection. When joining two pieces of pipe together, say two 1/4 inch pieces of pipe together, there's really two ways to do that, two ways that I've been using anyway. One would be with the use of a fitting, where the 1/4 inch pipe basically fits into one end of this fitting, and the other piece of pipe fits into the other end. There's a small stop inside that causes the pipe to stop and not go any further. So this is one method to join the pipe together. I've got 3/8 inch fittings here as well. Another method is with the use of a swaging tool. This is a hydraulic swaging tool made by Hillmore. They cost $300 maybe, at least when I purchased this one. I had to buy these 1/4 inch and 3/8 inch fittings. I believe it was the 1/4 inch fitting I had to buy separately. So I got all of this for about $300, and I had to buy the 1/4 inch fitting because it didn't come with the kit. This cost me about $100 all by itself. So if you can find a kit with the 1/4 inch included, congratulations. Anyway, you take the end of this that you're needing to use, screw it on, and because it's hydraulic, you just press the trigger slowly. You'll see the mouth of this begin to widen out. Push this trigger and it releases. So this end just fits into the pipe. The trigger squeezed several times. It gets large enough to open up that pipe. Then you can take the other end of the pipe and simply fit inside of the swaged end. And it's a very handy thing to have. I use it with every install that I do. There's also the manual version of that, which really does nothing more than frustrate me whenever I try to use them. These devices are manual swaging tools made by Uniweld. And what you're doing is you're just sticking this smallest end of this tool inside the pipe and then hitting the other end here with a hammer. And you do that while you're holding the pipe in your hand. It's a very difficult thing to do. It's a slow process, and especially if you're trying to swage a piece of pipe that's connected to a component like that's already connected to your evaporator, the last thing you want to be doing is to be hitting that piece of pipe with a hammer, because you may dislodge it free from the evaporator itself, and now you've got another problem to deal with. So I do not typically use these very much. I find them more frustrating than anything. And once you get your lines all brazed together, the system is ready to roll. It's always good to load the lines and components with dry nitrogen between 100 and 150 psi, pressurize it. Then you can check all your joints to see if you have any leaks. The easiest way to do that, the cheapest way, is just to use your standard detergent liquid. This is some detergent I believe I got from one of the sites. It was hanging around the sink, so I dumped some in this little water bottle, and I continue to use that stuff to this day. I find it to be just as good as anything. They also sell this gas leak detector. It is thicker. It's almost like molasses. So it does take a little more pressure to form the bubble, whereas the detergent is very light and it doesn't require much pressure to cause the bubbles to enlarge. So you can see that you've got a leak there. But this stuff does have its advantages. It doesn't drip off the pipe quickly, so it stays for minutes and minutes. Doesn't dry off as quickly as this stuff does. So I do like this stuff. I don't want to downplay it, but there are other things you can use if you run out of this and need something in a pinch. Another method for detecting leaks is by using an electronic device. This is called the Prowler, and I think I paid $300 or $400 for it, and it's been worth every penny. If you get a system running, it's been working fine, then all of a sudden you're noticing or someone else is noticing that it's leaking refrigerant. Now it's your job to find out where that leak is, and because it's been maybe months and months since you charged that system, it's probably a very small leak. Finding small leaks in our shuttles in tight little spots is not easy to do. Having one of these guys is the trick, I think, to finding those kinds of leaks. So basically you're just taking this nozzle end and inspecting, using it to sniff out, if you will, around those areas that you suspect might be leaking. And if there's just a hint of refrigerant in the air surrounding that or on that surface that you're inspecting, this thing will give you a audio clue that you're getting close to it. The faster and the stronger the beeps, the closer you are to it. And I really recommend using something like this.